Hi guys, welcome to Learn Electronics Repair. I have this to fix today, if I can. So this came off an air conditioning unit, compressor I think. Something has obviously happened here. Yeah, so Arrghhhh Golf 18, okay. So question is, can I fix it? These things can be really expensive to replace actually, so something that's well worth repairing if you can. Okay, that's a bit attached. Oh yeah, look, it's fastened onto some big devices down there. Okay, that's why that's kind of like springing around. And this is where it's all gone wrong. Now I do happen to have a bit of information about this. I asked him if he would bring it in as it was on site, but he didn't. But I do have a photo, so let me show you what's gone wrong with this one. Okay, and here we are, so we can see what happened to this. Yeah, looks like it kind of like spat something over there. Yeah, so that's what went wrong with it. It came in minus the lizard, but there you go. So that is the cause of the problem. That bit has been resolved now. Let's see if I can fix any other issues that are on here. Okay, so we can see what's gone wrong with this. Yeah, we know the cause of the fault. The question is, what's actually faulty now? Looking at this, this is where the power comes in. It's marked live neutral. There's a high rated fuse here. There's another one that is blown. Probably for good reasons, as we know. So the fuse is blown there. I would think that more than 3 amps is more than enough to fry a lizard internally. I would have thought, okay. These are effectively, there's a relay which might be wired across that NTC. Actually, that's quite normal. NTC sort of looks okay. There's also a relay starter and relay power, so there's 2 relays here. This looks like a filter, capacitor, various MOVs, various there's filter components. So the power comes in here. There's 2 large capacitors here, so 400 volt 680 mic. I don't think there'll be any voltage in them, but you know what, it's probably best to find out using this than find out the way the lizard did. So we'll see. No, there's no voltage in that. There, these are in parallel with each other. I can see these 2 are connected together. Yeah, they're connected in parallel with each other. This is the negative end that goes off up into this lot somewhere. You would think then, pretty certainly, there's a bridge rectifier somewhere here, so these will be charged with DC, certainly not with AC. Can't just see that at the moment, but it must be here somewhere. This is in the area. This is LNK304P. I wouldn't be surprised if that's maybe involved with some sort of startup supply. It's certainly behind this area. Okay. That looks like a bridge rectifier. Smaller than I might have expected, but there again, probably the stuff that runs on DC doesn't probably run on a great deal of current. This looks a little bit distressed maybe. There's another capacitor there. Oh John, what's that thing? 500 volt. Okay. That looks like some sort of standby supply. See this TNY? That's a little power supply chip. TNY will be powering this coil. This will be the output side. So this area is some sort of power supply, I would say, for all this. This will be the microcontroller, some latches or buffer type chips, okay? There's like a lacquer coating on this, especially in that area, actually. You see it reflective, yeah. So that's kind of what that is. Maybe some things under here. Some sort of chip there. Some large power devices. That looks like a bridge rectifier. So that's probably where the bridge rectifier is. Yeah. Looking at this now, power seems to come in this way, through, and then, yeah, I can see it, guys. So, power's coming in down here, live neutral, okay, running up this way and this way. These are two, effectively, inductors, okay, filters. Then this runs up here all the way up to, this is one of the AC inputs. The other AC input will come via the other path up here somewhere, okay. Then we have the plus and minus. In fact, it's marked minus. It's not marked plus, but that must be the plus. And then that comes down towards these large capacitors. So that gives us some idea, okay, of what we have. Right, let's get rid of this lizard residue and let's have a closer look. Well, it comes off. That's the first thing. Yeah, it comes off. A piece of something's just come off the board there. Looks like a bit of the lacquer. Okay, that's pretty much clean. Looks like it's just burnt the board a bit just here. This must be where it's arced across. Like a charred bit just there. Try to just get rid of that actually. Okay, that's a lot cleaner. I've cleaned this area here as best I can. Okay, so that's where it's arced over. We can say that much for sure. I think with this one, initially, let's replace the fuse. And I should be able to track through from here up to the input of the bridge rectifier, okay? As far as that. There are some large power devices here, so assuming I have power both sides of the AC and I have a connection from the plus and minus to the capacitors, we can check for shorts in this area. We can check on these large power devices for shorts. There's some sort of thing soldered under there. That's that thing. I'm not sure if you can see it, but it kind of like has legs on either side. Probably a bit difficult to determine if that's working or not. Okay. The other thing I'd like to do as well is just checking all that out for any obvious problems. Is have a look to see if we can figure out where this is in the circuit. What arced over to what, okay? That might help. And if we can pretty much say all this stuff's okay, I'd give them this back and say, right, go and try it. Right, let's have a look. So, first things first. This is neutral. It says power neutral, power live, okay? Brown, blue. So this is your power neutral. That runs all the way up here through this inductor, all the way up here, and that will end up on one of the AC inputs. There, so continuity to there is good. The other one is here. Live. Now, I would have thought that was connected into this lot, but it isn't. So let's see where it's actually... Oh, it is. I'd expect that connector there because this is the main path for the live. So this seems to go through a relay here. Connects to there. So that's like a relay when it's powered up. But the power must get in to power the relays up, if you see what I mean. So let's see. This is where the live goes from the other side of the relay via the inductor to this side. And I would have thought that would find its way one way or another to the other AC input. So this one is the neutral and this one should be the live. And it doesn't. Okay. So there's no path from there. Now we have the fuse that's blown. But is that fuse, which is that one? Yeah, that one. Is that fuse in the path of this? Yeah. I don't think it is. Let's have a look. So, other side of the fuse. Ah, this goes to here where something blew. And then it goes to the NTC. Yeah, you'd expect that. And then it goes off up that way. So, this path is the startup relay start. We can see the switch contact there. Doesn't go back to here though. The question I'm wondering is how it starts up, because obviously something has to switch this relay on before we get power to here. Okay. This is where it blew. Now that one, this is the other side of where it's blown. Okay, that one. Where's that go to? What comes down here and along here? Is this ground? Oh, we have some more connections here. Live and neutral. Okay, there's some more live and neutral. So that's on this connector. So CN CPL live, CN CP neutral. That's a live and neutral as well. Possibly switched from something. And this live and neutral seems to be permanently connected, but via the relays. Okay. Yeah, so what seems to have happened is connector live, this one here, has arced across to here, but this is also live via the fuse to live. Now you would think connecting live to live wouldn't be a problem unless this thing runs on more than one phase. I mean, it could be a 3-phase thing. I'm no expert on that stuff at all. But that appears to be what's actually happened here. And if the fault was this far back in the circuit, all it would do is just disconnect the power from everything else, which would suggest that up here there isn't any problems. So my theory goes. The only other thing I can't quite figure out is how this live gets to there, because it must do somewhere. Okay, so I figured it now. Just a little bit of poking around there, guys. So this live here, which comes through this relay, so obviously we have no connection at the moment. That goes to there. That goes to this filter and onto here. Okay. this pad, and that goes to this thing here. Can you see the pin there, which connects to the pin there? So that's that big thing that says CT, which is a coil, a little transformer or something, a little transformer. So it goes via that little transformer coil. And then that goes to this thing which says CN coil 1. Okay, and that is this thing. So from here, CN coil 1, just get into here, goes to one end of this coil, and the other end of here, that one is the other AC input on our bridge rectifier. So the power comes the route I've just shown you via this little transformer, via whatever connects onto here to there. So that's how the power actually gets up to there. I don't know what's connected to there, which in itself makes this a problem to power up on the bench. I mean, I could short those, but I honestly have no idea. Whatever it is, it's got to be something of low resistance because the power gets to here. Okay? But I think we can assume all this is probably okay. So, bridge rectifier. That reads like a diode. That reads like a diode. And the opposite way around should read like open. Okay. And then with the black on the AC to here, this is the negative end. Reads like a diode. Reads like a diode. And the other way around reads open, basically. A little bit of a resistance there. It's climbing up. I think something is charging somewhere, probably a capacitor. There's some big capacitors on this circuit. Yeah, got open now. That clearly comes to this end of the two capacitors from here, which is minus to here and here. And we can see that's the negative end of our two capacitors. And then from here to here, you would think, but it doesn't, goes to the positive end of the capacitors. It goes to something there. So we have two devices here. Yeah, in fact, you can see now that comes through here. So this is switching power somewhere via something. FRD, IGBT. So one IGBT. No shorts there. You can see this is high voltage because these slots that are cut in the board. Well, that means like a diode junction. That doesn't. This could be a MOSFET. Do I see open this way round? I do. And that reads open. That reads like a diode. But not to there. This could be a double diode, you know. Look, you see how it reads to both ends to the center. Is that a double diode? It's almost impossible to see down there without unsoldering that. It looks like a double diode. Oh yeah, look, you can just see the symbols of the double diode, yeah? You see down there? Just round towards the center pin. I can see them. I'm hoping you can see them. Just get the light in the right. Right, you can see them now, I think. Okay. Common cathode. So that reads like it should do in the circuit. Right, I honestly think with this one, based on where the fault is in the circuit, that literally just arced over here and blew the fuse. I don't think it's done anything else. Could have damaged the relay contacts, I guess. I could try and power these relay coils up and have a look, but the other option would be to unsolder them. Could have done, but I think it's more likely it's just blowing that fuse. And there we are. Okay. T. I'll probably have one of these. Look, T3.15AL. Okay. Just clean that little bit as well. Actually, I think that's some sort of writing. Yeah, it is. Writing. I'm just looking now for any other issues around here. So, the NTC... well, the current didn't flow that way, so I'm expecting that will read as it should do, like a low value resistor. Let's have a look. 113, a bit higher than I expected that to read. Okay, I would have thought that would read a bit lower than that, but I don't have anything to compare it with. Okay, and this here, this ZNR, so this is a metal oxide varistor. That reads, well, it's going well into the mega ohms. Probably going to read open eventually, and that, if that failed due to the voltage from this, then MOVs, which is this, they explode. These things explode. It has a cover on it, so let's have a look. That has not exploded. Those things, if they fail, you will know about it. Okay? Because they go bang. So I think we can say that's okay. And what else connects to here is, well, the fuse coming in we know about is something from here. That goes that way. It reads quite high. Let me just see if I can see what that is above the fuse. Well, there's nothing there. There's no component there. There's a capacitor. This is that chip. I wasn't totally sure what it does. LNK304. We can have a quick look. Yeah, this is more of this coating stuff. I honestly don't really know where that goes. There's a pin coming through the board here, just above the fuse. But this side is all surface mount. What's this thing? LNK304PG. Well, that is this thing. So this is a DC to DC converter. No isolation. It's like a buck converter. In fact, it is a true buck converter, I think. So there's no isolation. It's a buck converter. Just gives a different DC output. I'll just give that area clean as well. Okay, so I've cleaned it up. It looks okay, actually. I don't have one of these. We know what it is. It's a DC to DC converter. There are two diodes though here, so we can check these to see how they look. So that reads okay, like a diode. Yeah, it has like a high read in the other direction. So that looks okay. There's another one here. That looks okay. Then we have the bridge rectifier, also in the same area, so we may as well just check. So these are the AC inputs. I'm not sure if this was directly connected to there, but while we're here, that reads okay. This one reads okay. And then that's the other output, negative. So black to here, reads okay, reads okay. No short on the input, okay. So that looks all right. All these other components around here look okay. This NTC read a bit higher than I expected. What is it? Let's see. So 100D-9. I think that's actually a 100 ohm in cold conditions. Let's check the data sheet. Yeah, here's the data sheet for these. Okay, so we can see that 100D-9 is a 100 ohm plus or minus 20%. So I was reading about what, 110, 120. That's fine. Actually, that's within spec for that one. So that is also okay. And lastly, the large capacitors, which are in parallel. I shouldn't read a short across them. So I think if there was, it would blow the big fuse, and we will test the big fuse. So this is not actually lastly, but it'll take a while to charge up. Yeah, they're charging. So that's okay. And we have one more fuse down here, which is like the main power input. That reads okay. So given a job like this one, we have to make a decision now. In my opinion, because of where the fault occurred, probably everything further onwards is okay, because what would have happened when we got that arc over is it blew that fuse and disconnected the power to everything else basically. The short appears, in fact it was, because you can see where it went, between this live and that live. Now, technically speaking, that shouldn't happen. Yeah, it shouldn't arc over unless the phase is different on the two, so one of the lives and one of the neutrals. I mean, this is all AC. I don't believe it has to be in phase, but hey, I'm not an expert on these circuit boards. So something like that. Or we have a situation where this is running off one phase of a three-phase and this is running off another phase. Maybe. Again, I don't know these air cons, but I do know the big ones like this came off often do have a three-phase supply. So you guys might know about that. So put all those factors together, and I think I've cleaned enough of this off now. So minus any more lizards, it's not going to arc over again. I think we can say that is cleaned enough. Put all those factors together, and I'm happy to give this one back to him and say, hey, go and try it. But of course, there are no hard and fast rules when it comes to this fault finding. This is a kind of down to your own experience, basically, how much you've learned over the years doing this and what you're comfortable with. I'm pretty confident with that one. If you think different, down there, let me know, yeah? Okay, so one lizard repair, I think fixed. If not, you'll see it again. But I'm fairly confident you won't see this one, okay? But I'm sure you will see lots of more things being repaired on Learning Electronics Repair. Come back and we'll do some more. Ciao for now, guys.